Welcome, everyone. Today, we're diving into the intriguing Fermi Paradox. Imagine the immensity of space, yet it feels eerily silent. Why haven't we encountered other civilizations? Let's explore this mystery.
It's fascinating, isn't it? With billions of galaxies, the odds seem high that we're not alone. Yet silence. Could it be we're looking in the wrong places or using the wrong signals?
Or maybe we're not interesting enough to make contact with. What if advanced civilizations see us as we see ants? Too simple to bother with. That's a humbling thought.
Could it be technology? Perhaps they're communicating using methods we haven't discovered. Imagine if we're missing out on a cosmic conversation because we lack advanced tech.
Interesting points. As we ponder these possibilities, remember the sheer depth of our galaxy. One question remains: are we truly alone? Let's keep this discussion going in our next section. Reflecting on the history of the Fermi Paradox, it's fascinating how physicist Enrico Fermi, back in 1950, casually asked, "Where is everybody?" amidst lunch with colleagues. His question still echoes today, provoking us to reconsider our place in the cosmos. Has our understanding expanded since then?
Indeed, Michelle. What fascinates me is that even though Fermi's question is over 70 years old, it persists. Our technological progress has skyrocketed, yet whispers of otherworldly intelligences remain out of reach. Are we bound by cosmic irony where the more we know, the more we realize how much we don't?
But isn't it possible we're romanticizing the past? Imagine if the search for extraterrestrial life was driven more by scientific curiosity today than by whimsical pondering back then. Maybe our approach should be more logical and less emotional.
While logic is crucial, we can't overlook cultural influences. Sci-fi novels and movies from Fermi's era painted vivid images of alien life. These stories fueled imagination and exploration. Could it be that blending emotion with science pushes us to explore further and dream bigger?
We're touching on something profound here, the intersection of history, emotion, and science. This nuanced blend keeps the Fermi Paradox alive in our minds, driving humanity's quest for answers. Let's explore more in the next section and see where this leads us. As we delve deeper into the scale of the universe, it's vital to grasp the enormity of what we're dealing with. The universe is vast beyond comprehension. How does this scale impact our search for life and our understanding of the Fermi Paradox?
The scale is staggering. Billions of galaxies, each with billions of stars. It's easy to feel insignificant. Could it be this vastness is why we haven't found anyone else? The universe is simply too big for us to communicate across such distances.
But if life is out there, shouldn't the sheer number of potentially habitable planets increase the chances of contact? Or maybe we're invisible, like a tiny needle in a cosmic haystack. We might be missing signals hidden in the space-time fabric.
And then there's time. Civilization lifespans might be a blink in cosmic time. Perhaps we've missed others or are yet to encounter them. The universe's scale isn't just spatial but temporal, and we may need to rethink our search strategies.
Excellent points, everyone. As we ponder these vast distances and timelines, we're reminded of both our smallness and our potential. This paradox urges us to seek answers beyond technological and temporal limits. Let's continue exploring. Now, let's focus on the rare Earth hypothesis, a potential solution to the Fermi Paradox. It suggests life is incredibly unique to Earth due to a mix of rare events and specific conditions. Could this be why we don't see others out there? How does this hypothesis change our perspective?
It's humbling. The right star, planetary position, and conditions like plate tectonics and a large moon might be rare. If Earth needs such a unique combination, perhaps life elsewhere is scarce or non-existent. It's a daunting view of the cosmos.
But isn't it also possible we're underestimating life's adaptability? We find life in Earth's most extreme environments. Maybe life can thrive in conditions we can't imagine beyond those found on Earth. Are we limiting our search by aligning with this hypothesis?
True, Ryan, and thinking about Earth's history, we see continuous evolution and survival amidst harsh conditions. Could the same happen on other worlds, even in environments vastly different from ours? Life is potentially more common if we expand our search criteria.
Fascinating insights. Whether Earth's uniqueness supports the rare Earth hypothesis or not, it's clear we must broaden our horizons in the search for life. Let's digest these ideas as we progress, continuing our quest to unravel the universe's mysteries. So let's explore the Great Filter Theory, a central concept in the Fermi Paradox. It suggests that somewhere in the timeline of life, there is a barrier preventing civilizations from becoming advanced enough to communicate or travel across galaxies. Are we facing it now, or have we already passed it?
The thought that the Great Filter could be ahead of us is both terrifying and motivating. If true, advanced civilizations rarely survive long enough to make contact. Are we overlooking crucial self-destructive tendencies in our pursuit of progress?
On the flip side, what if we've already overcome the Great Filter? Maybe life is so rare that surviving this far is a monumental achievement. It instills hope, but also a heavy responsibility as potential civilization pioneers.
I wonder if the Great Filter is more environmental than technological or social. Imagine if universal threats, asteroid impacts, gamma-ray bursts pose limits that many planets can't escape. It's a humbling reminder of our cosmic vulnerabilities.
The Great Filter Theory reminds us of the stakes in our quest to understand the cosmos. Whether it's behind us or ahead, it challenges us to pursue sustainability and exploration. Let's ponder these possibilities as we journey on. Let's delve into the profound question of technological versus biological limitations in the Fermi Paradox. Are our technological advancements capable of overcoming biological instincts that might impede our progress toward interstellar communication?
It's a compelling thought. What if our technological progress outpaces our biological and social evolutions, leading to crises we can't biologically handle? It suggests a delicate balance between innovation and our primal instincts.
I'll consider this a very biology that grounds us may also be what propels us forward. Our curiosity, our drive to explore, and our survival instincts might actually spur technological leaps. It's a dynamic interaction, not just a conflict.
True, Ryan, yet we must recognize potential biological limitations like cognitive biases, which may hinder our ability to comprehend or create tech needed for extraterrestrial contact. Understanding these barriers is crucial.
We're exploring rich territory here, how technological drives and biological instincts intersect. This can shape our journey into the cosmos. As we consider these limits, we're reminded of our need to innovate wisely. Let's carry this curiosity and caution forward. As we dive into sociological considerations, it's crucial to ask, do specific social structures or cultural dynamics prevent us from making contact with extraterrestrial civilizations? Are we assuming other societies function like ours?
It's intriguing to think about. Maybe other civilizations have completely different social dynamics prioritizing secrecy or non-interference. Are we projecting our own societal norms onto them and expecting the same behaviors?
Consider this: perhaps advanced civilizations reached a level of societal progress where they decided interstellar communication isn't worthwhile or ethical. This shift in values might make them invisible to us.
I agree. Additionally, biases in our scientific approach could bind us to forms of communication beyond our comprehension. How can we shift our paradigms to consider other possibilities?
As we progress, let's examine the zoo hypothesis, which suggests we might be under observation by advanced extraterrestrials intentionally kept unaware as part of their study. It raises the question, could our galaxy be a cosmic reserve where intelligent life grows naturally without interference?
The zoo hypothesis is both fascinating and unsettling. Imagine being watched without knowing it. If true, it implies a power dynamic where we're seen as primitive or unready for contact. Does it reflect discomfort with our own technological ethics and responsibilities?
Maybe it's a form of cosmic kindness. They could ensure we develop unhindered by external influences, waiting until we're mature enough for contact. This approach parallels wildlife preserves on Earth, where humanity balances protection and observation.
Alternatively, consider simulation theory, where our reality might be an artificial construct. This suggests we seek extraterrestrial life on a different plane entirely, formatted by a creator civilization. How do we grapple with the potential artificiality of our existence?
Both hypotheses challenge the boundaries of our understanding. Whether we're under our observation or part of a simulation, it invites us to expand our perspective on existence and the universe. Let's continue examining these ideas as we unravel the cosmos together. Stepping into the implications for humanity segment, we must ask, what does the Fermi Paradox mean for our future? Could these unanswered questions about extraterrestrial life reflect deeper truths about human nature and destiny?
It's an existential mirror. The silence of the universe forces us to reflect on our communication practices and how we interact with each other and the cosmos. Perhaps it's a gentle push to mature as a species before we're ready for cosmic conversation.
Or is it a call to action? The absence of contact might inspire us to elevate our technology, ethics, and cooperation for reaching beyond Earth's confines. In pursuing the paradox, we may realize our potential on Earth itself.
And we can't forget the philosophical shift it demands. Our solitude in the universe could redefine our values, prompting us to prioritize sustainability and unity for survival. Are we prepared for the responsibilities of potential first contact?
These insights emphasize that the Fermi Paradox is not just a mystery, but a journey of self-discovery. It challenges us to evolve and reflect on our place in the cosmos practically and philosophically. Let's carry these thoughts forward. As we draw to a conclusion on the Fermi Paradox, consider the ongoing pursuit of this mystery. Each discussion, theory, and question uncovers more about both the cosmos and ourselves. Are these explorations as much about finding others as they are about understanding our journey?
Absolutely, Michelle. The Fermi Paradox compels us to reassess our place in the universe. As we advance, we must ask whether our efforts enrich our species. Are we laying the groundwork for future generations to continue exploring?
The mystery challenges us to push the boundaries of technology and imagination. It could foster a collective desire to probe deeper. As we explore, are we unknowingly shaping a shared human identity in the quest for the unknown?
Yes, Ryan. And let's not forget the philosophical implications, the possibility that our solitude is not loneliness but an opportunity to forge a future aligned with cosmic harmony. Are we ready to embrace this potential?
Fermi Paradox offers a canvas for reflection and aspiration. It fuels our desire to learn, evolve, and connect. As we move forward, let's grasp these lessons, making our quest as profound as the answers we seek.